Okay, so we've been playing around with the electric field. I want to do one last thing. I want to plot the magnitude of the electric field as we move further away from a point charge. And I'm doing this now because I'm going to want to do it again later for something else. So let's start with this program. It's a new program, but it's basically the same thing. It just calculates the electric field. Nothing new. This is the same thing. I put the charge, a 3 nanocoulomb, whoops, that should be 3 times 10 to the negative ninth, nanocoulomb charge at the origin, and my observation location's at 0.5. I don't display the electric field, but I've made a function to calculate the electric field. Okay, I want to start with the charge here and then move it further along the x-axis and make a graph. So the first thing we're going to do is to make a graph. So up here I'm going to put tgraph is the name of my object, which is a graph, and the x title is going to be equal to, let's just call it x in meters, and the y title is going to be equal to ex in newtons per coulomb. So ex, because I can't plot the electric field's a vector. I can plot the component, the x component of the electric field. Why am I hitting my hands together like this? See, I'm like talking with my hands and hitting it. You can't even see my hands. I don't know why I'm doing it. Okay, the next thing I need is a function to plot. So I'm going to call it f1 of type g-curve, and let's make it blue. And that's it. Okay, so now I'm going to, this is just a test to make sure things are working. Let's say, let's start off with x equals 0.05. That's where I'm going to start. And now I'm going to move it dx amount of 0.002. I just picked that. I don't know. And so I'm going to calculate the electric field. I'm going to say while x is less than, let's go to 0.15 and see what happens. 0.15, do the following. Step 1 is calculate the electric field. I don't even have to do that. Let's say E temp equals E. I need this R. Our observation location is going to be equal to the vector x, 0, 0. Now I can use my formula over here and say RQ1, RQ1, RO1, Q1. Now I can plot this value. So I'm going to say f1.plot. So remember, when you make a graph, there's a couple things. The most important thing is up here, define the function. This makes it so that you can give it an x and y title. You give it a total title if you want to. I guess I should do that too. Let's put that up here. Let's see. Electric field due to point charge. How about that? Are you happy? Okay, and then the next thing after you make the g-curve is to add a data point to there. And so f1.plot using the name of the g-curve and .plot gives me my x and y value. So my x value is going to be x. My y value is going to be etemp.x. So I have to do .x because that's the x component of the electric field. I could do magnitude also, but and it'd be the same thing. Now I'm going to increase my x value, and that should be it. Let's save it, and let's see what happens. Oops. So my graph is down here. That looks pretty good. And you see this is a 1 over r squared graph. I'm pretty happy. And I don't think I'm even going to change it. So that's the end. Graphing. I'll see you guys later.